Okay. Next we have Simone Mainardi, who will be talking about augmented network visibility with the help of sub-minute resolution metrics. Thank you very much. Or give him a hand.
Hello. Thanks for being here today. And yes, in this presentation, we are going to see actually the benefits of having high-resolution metrics in the field of network visibility. And then in the second part of this presentation, we are going to try and use open source software to build an actual network visibility solution. And we will see nTopNG for the monitoring, Grafana for the visualization, and FluxDB for the store of data. But let's start with network visibility. Okay. Can you hear me okay? Yeah. So, well, let's start with network visibility. In general, network visibility is provided by means of metrics. These metrics can be simple metrics, such as the bytes and packets transmitted or received by a given host or by a network. There can be also other metrics that include layer 7 application protocols. For example, the amount of YouTube traffic done by this host or by this network. But there can also be more complex metrics, such as moving averages, exponentially weighted averages, these kind of metrics. But the point is that metrics are sampled. This means that there is no way to have a 100% reliable, accurate representation of the real metric, because we only have samples of the metric. This means that at fixed interval of time, we pick the value of the metric. So basically, there is an amount of time which is basically equal to the sampling interval that is completely unknown. This means that, let's take this chart, for example. We have a metric and its evolution in time, and we have two samples, S1 and S2. Between S1 and S2, nothing is known. Nothing can be said. We don't have an idea of the behavior of the metric between S1 and S2. So it could have followed the green path, the yellow, or the blue path. But in practice, actually, we don't know. We have only S1 and S2. So it's pretty clear now that the shorter the sampling interval, the closer we can go to the actual metric, the closer we can go to the real metric. So it's beneficial to be able to reduce this sampling interval. Let me show you this with an example. In this example, I'm going to transfer 10 gigabytes of traffic 2 times. The first time I'm going to transfer this 10 gigs over a free link, and the second time, I'm going to transfer the same 10 gigs over a fully utilized link. And I would like to show you what happens if we use 5-minute sample on one hand and 10-second samples on the other hand. To do this experiment and to make it reproducible, I'm going to use iPerf to send the data and nTopNG to actually do the monitoring. And we are going to see nTopNG in detail later in this presentation. So let's start with a 5-minute samples. The first bell-shaped curve that we see in this chart is the metric of traffic captured during the 10 gigs transfer with a free link. The second bell-shaped curve is the same metric, the same traffic metric captured during the 10 gigs file transfer over the fully utilized, over the congested link. Do you see any difference? No. The two bell-shaped curves are the same. So it's completely undetectable, the fact that the link was congested, if we use 5-minute samples. Let's see now what happens if we go from 5 minutes to 10-second samples. Well, as we can see from this chart, this is a different story. The first file transfer, it's a beautiful, straight transfer. And as we see, the metric almost immediately reaches the line rate of 1 gigabit per second. And it does a steady transfer, and it completes in a very short interval of time. If we look at the transfer over the congested link, that's really different, because we see that the throughput is not even 1/2 of the throughput done over the free link, and there's also a sawtooth behavior that we can see in this chart. So you see, going from 5-minute samples down to 10-second samples actually unveils patterns that are interesting and that are completely unnoticed if we use 5-minute samples. Again, these two charts, if you look at the time scale at the bottom, these two charts are two instances of a monitoring tool that are running and monitoring the same traffic, but one is taking samples at 5 minutes and the other is taking samples at 10 seconds. So why we should care about this? Well, there are many reasons. Let's see, we should care about having an high resolution, for example, to have a more accurate representation of the throughput that is received by our applications that use the network, because there are certain applications that are sensitive to the throughput. For example, VoIP calls or video streaming. This kind of application have certain requirements in terms of minimum throughput. And if we can't guarantee this kind of throughput, then the user experience can worsen, the application performance can worsen. So being able to monitor the throughput in an accurate way can help you in improving or even providing a good service for your applications. Similarly, another thing that you can do is to look at bursts that can go unnoticed if you use 5 minutes or 1 minute samples. Because bursts are not really good for the networks, because bursts tend to fill the queues of your network elements, so they tend to introduce jitters or increase the delays of the transmissions. So bursts are not really good in the networks, and being able to spot them can help you fix certain kind of issues. Okay, so now that we have seen the motivation and how useful it can be to have high-resolution metrics, let's see how we can build a solution using open source software. What do we need to build this solution? Basically, we need 3 pieces of software. We need a software that can do the monitoring and that can see the packets, so it can provide high resolution, it can generate high resolution metrics. Then we need a data store that is able to ingest high resolution metrics and provide timely response to the queries. Because if we use high resolution metrics, we end up in generating 100 millions of points per day in real world networks, in corporate networks. So we need a really good data store that can, on the one hand, store the metrics, and on the other hand, provide you response to your queries in a timely way. And least but not last, we need a visualization tool that can show us the relevant behavior, that can allow us to do the drill down and to detect or to analyze analyze and alert on our traffic. So the solution we have proposed is composed of 3 open source software: nTopNG for the monitoring, InfluxDB for the store of data, and Grafana for the visualization. I'm not going to go into the details of InfluxDB or Grafana. I mean, we have had Carl right before me. So what I would like to focus now is nTopNG, the monitoring tool, because I am one of the developers of nTopNG, and I would like to tell you how we brought nTopNG from 5 minutes samples down to 10-second samples for the generation of 10-second samples. So nTopNG is open source. You can fork it on GitHub. You can download and try it. It's just an open source software for the monitoring of your network. And we have 3,300 stars now on GitHub and counting, so feel free to download it and test it. So the architecture of nTopNG is multi-threaded. This means that basically we have one thread that is reserved for the capture of packets. And then we have other threads that run in parallel and are reserved for the generation of samples. So in our recent activity, in our recent work, we extend those parallel threads for the metrics generation, and we change them so that they can provide metrics at up to a resolution of 10 seconds. So we were using RRDs. RRDs are another store for metrics based on plain text files, so based on files. That is basically used if you want sample in the order of minutes, basically. Otherwise, it will be too slow. So we extended nTopNG to produce 10-second samples and to push those samples to the InfluxDB database. So how easy is to set up and configure nTopNG to generate 10-second samples of your traffic using InfluxDB? Well, it's pretty easy because you just visit the configuration. I'm going to show you a quick demonstration in a while, but it's pretty easy. You just visit the preferences of nTopNG, you set up the URL of InfluxDB, a database name, and you are done. nTopNG will start pushing data into InfluxDB. And on the other hand, if you want to build your dashboards using Grafana, for example, what you have to do is only add a data source to Grafana, an InfluxDB data source, to actually connect to the same database used by nTopNG. InfluxDB host, database name, and you are done. With Grafana, you can start doing experiment and creating dashboards, for example. And as we can see in these two charts, I have recreated the same dashboard of the file transfers. I've recreated the same dashboard using Grafana. And as we can see, obviously there's a 100% match between the two charts because Grafana and nTopNG are both pulling data from InfluxDB for the visualization. The other interesting thing that you can do with Grafana is the alerting. Alerting that now you can bring down to a 10 seconds resolution. This means that you can evaluate condition every 10 seconds. So you can set an easy threshold. If you want to monitor a web server, you can set a threshold to be timely alerted if the traffic of your web server goes above a certain threshold or goes below a certain threshold. The point here, the interesting thing here is that you can create alerts with an evaluation frequency of 10 seconds. So you can receive a notification, you can receive an email very, very quickly when something happens. Let me show you now a quick demo. I want to show you how easy it is to set up this kind of 10-second monitoring using the tools. Okay. So here I'm going to start NTOPNG, which is the first tool for the monitoring of data. Do not look at the other options that are not really relevant for this demo. The interesting thing here is that we are going to run NTOPNG using interface EN01. I'm going to start it. So now it has started monitoring the traffic on this laptop. So now I'm basically monitoring the network traffic that my laptop here is doing from and to the internet. Yeah, because I need to start. Now I can also start InfluxDB, same thing. So now, yes, I've started InfluxDB. So NTOPNG is generating 10-second samples and posting them to the InfluxDB running on the same host. Third, I also run Grafana because I would like to see the dashboard in action. Okay, so let's see what happened. I can point my browser to localhost 3000. I have created a dashboard here. Here we are. So this is a dashboard that I have created using the Grafana and connecting to the InfluxDB that is storing our 10-second samples of the traffic. I created a dashboard that is showing me the throughput of the network interface and the traffic of certain relevant application protocols, including DNS, Dropbox, and Google. So this is the traffic. What I can do now is to create something more interesting. Maybe I can set a time interval of now minus 5 minutes, and I can set a refresh of 5 seconds. So this dashboard is going to refresh every 5 seconds, and let's see if we can generate some interesting traffic. Let me do. I'm going to download an ISO of Ubuntu, and if I go back to the dashboard, we see that the throughput has increased to almost 60 megabits per second. And you also have the throughput in bytes and packets shown right into a Grafana dashboard. You can use Grafana. I mean, Grafana is a very useful way to create your own dashboards, and you can pull also metrics from other data sources. So you're not limited to the use of NTOPNG, because maybe you have another data source that is monitoring the number of request and response of your web application. So you can combine in the same dashboard the chart of the interface throughput with the chart of your HTTP requests, for example, to detect certain kind of anomalies or to detect peaks in the HTTP or in the response errors of your application. So yes, it's almost everything what I wanted to show you now. So let me wrap up. So we have seen that having high resolution metric can unveil certain patterns that are unknown or unnoticeable if we use 5-minute samples or if we use lower resolution samples. If you want to build your own monitoring solution, you can do that using open source software, NTopNG, InfluxDB, and Grafana. And least but not last, we are growing and we are hiring. So if you are interested, if you like networks, if you love packets, let's contact us. I mean, we will be around the whole day, so contact us. You can work from remote. We are based in Italy, but you can work from remote if you want. So contact us, and we can start doing something together. That is my email. Thanks for your time. If you have questions, I'm here. So please feel free to question. Thank you. Yes. Okay, let's wait the mic, okay?
Hi. So on the demo, you showed applications in the graph, like Dropbox and Google.
Yeah.
How do you distinguish that, and do you
Yeah.
have to create a dashboard to filter for that
Yeah, sure.
specific application, or can it be dynamically populated? Or
Yeah. So NTopNG has an engine which is called Deep Packet Inspection. It performs a deep packet inspection of the real traffic packets to detect the actual protocol that is flowing in that particular time. So let me show you this. I can edit this stuff. And as you see, I do an InfluxDB query on the deep packet inspection, iFace DPI, and I can change the protocol. And here I have all my protocols that have been dissected by NTopNG. So I can pick another one. I can pick HTTP, I can pick Google, GitHub, or whatever you want, Instagram. So you create the dashboards of the layer 7 application protocols that are traversing your network. So those are application protocols. So this means that it's the layer 7 payload. So it's not a layer 4 protocol such as TCP or UDP. It's the actual application carried in the layer 7.
A question. The interval, the NTOP agent pushes the 10-second interval measurements to the InfluxDB. Is it still 5 minutes, or is it also 10 seconds?
No, you can choose that. You can choose that.
Okay.
Let me
Not
see.
only the measurement interval, but also the push interval.
Huh?
Because it collects every 10 seconds the interface statistics, and it pushes it the statistics to the database.
Yeah.
Also every 10 seconds or every 5 minutes?
Oh, the push is basically every 10 seconds, also the push to the database.
Okay,
You
so
can control the flash, but the point is that statistics are every 10 seconds. So you may see them with a little bit of delay in the database, but once they are in the database, they are 10 seconds.
Mm-hmm. Okay, thanks.
Okay.
So question, how are you doing downsampling of data in InfluxDB, if you are doing downsampling?
Yeah, we are doing downsampling. We are using continuous queries. This is one of the latest developments. Yeah, you
But
need to
then
roll
you
up.
save them to some other data source time metric in InfluxDB, and then you have to select another data source to see the historical metrics or what?
Yeah, that's true. That's true. Yeah.
Hi, Simone.
Hi.
So obviously what you're saying is 10 seconds is better than 5 minutes, I assume then.
It's not
One-
necessarily better. It could be useful depending on
you
what
get more resolution,
Yeah.
for example, and then maybe 1 second is more resolution than 10 seconds.
Yeah.
What are the main sticking points or problems going lower and lower resolution?
But the lower you can go, the more close to the real metrics you can get. The point is, do you really need to go so close to the real metric? The answer is, it depends. It depends on what you are looking. There is a phenomenon that is called microbursts. So microbursts because they happen at microseconds, during microseconds events. So they can create troubles in the network as well. You could be interested in inspecting microbursts. If you need to inspect microbursts, yes, you need to go to the microsecond resolution. So you need hardware timestamping, you need dedicated network cards, you can do that. So it depends. It depends. The answer is it depends. So the higher the resolution, the more you can see. This is for sure. But it depends. You can be happy also with 5 minutes. I mean, I don't know. It depends.
This is plain Ethernet sniffing, let's say?
Yeah, this
Do you
is Ethernet
support
sniffing.
overlay networks like VXLAN and stuff like that?
Like what?
VXLAN.
Yes. I mean, provided that you can access the traffic, you can do this kind of monitoring. To do these 10-second samples, you need the traffic. So if you have overlay network, say if you have VXLAN, you can do that, provided that you can find a way to feed NTOPNG with the traffic that you want to monitor.
Hello.
Hello?
So you are not working with RRD files anymore, right?
Say it again?
You are not working with RRD files anymore, right?
No, you can choose that. It's an option. You can choose if you want to use RRDs or if you want to use InfluxDB.
Okay.
Both of them are supported.
Okay. About the alerts, do you send them to NTOPNG from Grafana? Or
Grafana has an alerting engine built in, and NTOPNG has another alerting engine built in. You can do email, Slack notification, this kind of alert. So you can create them in NTOPNG or in Grafana.
yeah, I mean it's up to you.
Yeah,
right?
it's up to you.
And as NTOPNG is an open source solution, I don't know if you have this information, but do you know how much host is enterprises monitoring with NTOPNG? How does it scale?
Yeah, it scales up to tens of thousands of hosts inside the enterprise. It can monitor many more hosts, but if you have an enterprise, you are interested in having more information for the hosts inside the network. So NTOPNG divides the host between your enterprise network and the rest of the world. So this is done for efficiency, basically, to save memory and for the efficiency of the software. So it can scale up, let's say, to 40, 50,000 enterprise hosts plus hundreds thousand hosts outside your network, your enterprise network.
But you use different instances of NTOPNG and
No,
or
a single instance.
one for 50,000 hosts.
Yeah, single instance.
And then if you want to monitor more, you need to set up another one?
Yes, you can set up parallel instances.
Yeah, but they don't talk with each other, right?
They won't talk with each other.
Okay, thank you.
Just a note, I know you guys are not, and gals are not aware of this, but if you keep talking in the back, in front, this is relatively loud. Of course, this room has really good or bad acoustics, we can debate this, but please keep it quiet, thank you.
A question related to a previous one. If you have ever experimented with use cases where the resolution is very fine-grained, like in milliseconds or something, and if yes, which are the most critical aspects to be considered in this kind of workflow and architecture in this specific kind of use cases, because the data volume could grow considerably.
Yeah. Actually, I didn't work on millisecond scales, so I didn't even try to push data into InfluxDB and chart them with Grafana, so I don't have an answer. We have worked on microbursts, but not using this solution, so I don't have an exact answer for this.
Thanks. Hi. Thanks for the talk. I'm just wondering if you're doing a lot of high-frequency sampling, how does that scale in terms of resources? What way is it managing RAM or CPU usage?
Now say it again.
I'm just wondering if you're doing a lot of high-frequency sampling, what way does it scale in terms of resources? How are you handling the likes of RAM or CPU usage if you're doing a lot of
Yes.
sampling?
So the point is that NTOPNG is real time, so it sees all the packets. The fact that we are generating samples at 10 seconds, it's not really pushing more pressure NTOPNG wise, because it is already processing and inspecting every single packet. So the point is just running another thread that every 10 seconds crunches some statistics, which is not really what impacts the performance of the software or of NTOPNG. InfluxDB wise, I can't really tell you the impact. I didn't do the certain performance or load measuration if we go from 5 minutes to 10 seconds. So InfluxDB wise, I can't really tell you. NTOPNG wise, I can tell you that this is not what is putting the highest pressure on the software, because NTOPNG per se is real time. So it already sees every single packet and it inspects every single packet that is monitored. Any other question? Okay, so thanks for your time.